Hello, children. Today I will be absent due to medical reasons. I have a back problem. Once you are at my age, you usually have problems with your muscles. What we're going to study now after triangles is quadrilaterals. Okay, it says quadrilaterals are plane shapes with four-sided and four interior angles. Quadrilaterals are given special names according to their properties. Okay, so here you can read the type of parallelogram of quadrilateral. Okay, parallelogram, rectangle, square, rhombus, trapezium, and kite. Okay, you have seen most of these last year in elementary school. What you have here are the properties of each of those of this type of quadrilaterals. You have to read them. Okay. Read them. This is important. The angle sum of a quadrilateral. It says an important property that we can use it together with other properties of quadrilaterals is to find the size of unknown angles. It says the angle sum of a quadrilateral is 180 is 360. Okay, this is important. The sum of the angles of a quadrilateral is 360. Here I have a few examples. This is done with GeoGebra. I will send you a link. But here's at the left bottom, you have all the angles A, B, C, and D, A, B, C, and D, and their angles, so the value of their angles. Notice that even though I move this vertex and the angles change, okay, look at how the numbers change, okay, and here the numbers change, the angles. What is happening is that always they add up to 360, okay? So if you have to find an unknown angle, you can use this property. For example, let's imagine that d is x. Well, you know that 96 plus 90 plus 78 plus d equals 360. Why? Because the angles, the sum of the angles of a quadrilateral is 360 degrees, okay? So this is the new property, a new theorem that we're going to be working with when doing the exercise of quadrilaterals, okay? So basically, this is it about quadrilateral. Read this part, okay? Here you have examples of how to measure. Here, for example, you have a triangle, okay? 1, 2, 3, 4, 5. 1, 2, 3, 4. K, N, M, L is a quadrilateral, okay? And, well, read these work examples, okay? Remember to work in groups up to 5 people, okay? Up to 5 of you. And you have to answer these questions, okay? You have to tell me which relations are there with each of these angles, okay? For example, is there a relation between x and this angle, okay? Try to think of all these are parallel lines. So you have to imagine if this angle is a vertex opposite, is there a way that I can convert this angle into this one to see the relation, okay? In this case, it says ABC is a rectangle. Let's imagine that this is point O. The triangle OBC. Can you think of which type of triangle is it? Okay. And in this case, for example, here you have two parallel lines and one transversal. Is there a relation between 110 and x? Okay. For example, in this case, you have 90 degrees. You can find this angle, and by doing the supplementary condition, you can find x. Okay. In this case, you have 4 angles, and you know that in a quadrilateral, the sum of angles, as it says here, the angle sum of a quadrilateral is 360. So you can do x plus 3x plus 4x plus 2x equals 360 because the angle sum of a quadrilateral is 360. Okay. And basically, this is it. And in this case, well, here you have quadrilateral and some triangles. Okay. Try to do this all. Okay. I will send you in the classroom, I will send you a link to this page so you can see how, if you move a vertex, how the angle changes. And even though you change the angles, the vertices and the angles, the sum of the angles is always 360. Okay. This works only for a quadrilateral. Okay, and this is it.